Hello everyone. Now in today's lecture we will start with unit number 5, which is about the mechanical sensors and actuators. Coming to the introduction, sensors and actuators play a significant role in almost all kind of instrumentation, process control, factory automation and machine control application. So during your various subjects, you might have studied that in case of factory automation, there are many conveyors and automated process takes place which completely depend upon the action of sensors. Whatever the input received from the sensor, based on that, actuators are controlled with the help of a microcontroller or a central control unit. So almost everywhere, sensors and actuators are useful. For simple understanding, consider the machine control applications such as the mechatronic system. A mechatronic system is an electronically controlled mechanical machine. Some example of mechatronic systems are robot, automated guided vehicles, cranes, numerical controlled machines, automobile engine, and tankers. In all these example of mechatronic system, we very well know that sensors play an important part. If we consider robots are successful in their working because of the sensory action. These sensor gives input to the microcontrollers and then microcontrollers control the functioning of actuators. Similarly in automated guided vehicles and so on. Micro mechatronic systems are mechatronic system but their dimensions are measured in microscale level. Regardless of their dimension, all mechatronic systems are composed of four prime components. They are sensors, actuators, controllers, and mechanical components. So whenever we talk about mechatronic system, at any level, either it is micro level, nano level, or it is at general dimension, there are four basic components: sensor, actuators, controller, and some mechanical components. So in the upcoming figure, I'll show a schematic diagram of the combination of all these components which comprises a complete mechatronic system. The plant could be an electrical motor. The meaning of load is simply the mass of the rotor along with the shaft which need to be rotated at a precise predefined speed. The output speed can be observed by using a feedback sensor. So here one of the diagram is given, a schematic flowchart. Consider a plant. This plant can be any mechatronic system. It can be aircraft engine, it can be some defense equipment or some consumer based products like automated water purifiers, automated or smart TVs. So that is a type of a process. So here plant relates with a kind of a process. So from that process, firstly sensors are connected which take inputs either from the environment or some of the process of that plant and gives input to the microcontroller. So that microcontroller comes under the processing unit. It is need to be understand that processing unit is already have some kind of control algorithm because of which the processing unit do a comparison between the measured value and the previously stored values, based upon which a decision is taken, and further that decision is transferred as a command signal to the mechanical component. Due to that mechanical component, it can be a linkage, it can be gears, or any mechanical component which produces a motion or some kind of actuation, and that actuation is further transferred to the plant, because of which the machines can move. Now here another MEMS based example is given, where power unit is there, then power converter is there. It can be analog to digital converter or digital to analog converter. Then there is a plant, and finally a load. But here in this case, a feedback device is attached which control the process and minimizes the error. Although the design and construction of macro scale and micro scale mechatronic system vary, but the principle behind the control interfacing remain similar. From control point of view, sensor will sense the signal and actuator will activate a control action. Depending upon the control requirements, sensors are chosen. The role of controller is to execute the control code for a given task. In its abstract form, a simple but exemplar control code could be: drive the actuator from position 1 to position 2 when event n is occurred. So when we relate this simple control code with the robotics, then we consider that uh, stepper motor will go from position 1 to position 2 when any kind of signal is transferred, or when sensor is going to sense a particular event, then it gives command to the actuator through the control unit that actuator will move from position 1 to position 2. The above piece of code is also known as control algorithm, which can be realized in a variety of ways through a broad range of sensors, processing unit, and actuating systems. The role of sensor in this case is to check whether or not the event N has occurred. If yes, it passes the information to a controller. On receipt of this information, controller generates necessary driving signal in order to drive the actuator, so that the end effector of the actuator can move from one position to the another. The act of observing the temporal occurrence of physical phenomena is called sensing, whereas the act of driving an end effector is called actuation. So further in next lecture we'll understand more about the sensing.